tRPC, probably the gold standard when it comes to having end-to-end type safety. You just update some fields on your server and your client automatically gets updated. But there is one tiny little downside to using tRPC. Both your backend and your front end, they have to be written in TypeScript.
Boo this man!
Everybody hates you.
I hate you.
He hates you so much.
Know your place, trash.
All jokes aside, TypeScript is a fine language, but it's not always the right fit for every single project. Sometimes you wish you'd be able to have the same kind of end-to-end type safety, maybe in a different language. And that's why I'm really excited to introduce Arri RPC for Golang. Now, for those of you that don't know, Arri RPC is an RPC framework that I've been working on that gives you end-to-end type safety, but it's language agnostic, meaning your server and your client can be in completely different languages, and you can still get this sort of end-to-end type safe experience. So let me just show you a little bit of what it's like to work with Arri RPC in Go. So here I have a basic Arri app. And this Arri app accepts a servmux from the HTTP standard library. This means that you can actually use it alongside existing endpoints that you already have in your app. And you could even scope your procedures to all exist behind a certain prefix like RPCs or procedures, so that all your regular endpoints, they're at some other place, and then all your procedures exist behind this prefix. Now, in this example here, I have two procedures that have been registered on the app. You have a say hello procedure, and you have a say goodbye procedure, and you can see them here. Say hello accepts greeting params as its parameters, and it responds with a greeting response. Say goodbye has the same parameters and the same response. Now on the right side here, I have a client written in TypeScript that has been initialized to communicate with this server. So my server is running on localhost 3000, and it has access to this same say hello, and it also has access to say goodbye. Now watch what happens when I make a change to our greeting parameters. Let's say, for example, instead of name, I want to accept a first name and a last name. Now I'm just going to hit save. And then if we look at the right side, you'll see that I already have a type error here in my TypeScript client. And all I did was update this struct in Go, and now my TypeScript client already knows, hey, name doesn't exist. It needs to be a first name and a last name. Now, the way that this works is that I am using the Arri CLI to actually start the Go server and run it in dev mode. And so you'll see here on the right, I'm just calling Arri dev, and Arri is essentially starting the server, but it also knows how to extract the type information out of the Go server. And that's kind of part of the whole Arri RPC experience, which is that any Arri server actually creates a plugin that is able to communicate with the Arri CLI. And it tells it, here's how you start the server, here's how you stop the server, and here's how you get the type information out of the server as well. What that means is that now anytime I add a new field, say like created at time.time, the Arri CLI, it detects, oh, okay, well, there was a change on the server, so let's restart it, right, just like you would in dev mode. And it also saw that, oh, our schema has also changed. And actually, let me fix that, that's a typo. Our schema has also changed, so we need to also rebuild the client. So for example, if I make a change to this without changing our schema, so for example, I wanted to return the first name and the last name, you'll see that we restarted the server as expected, but we didn't rebuild the client because the client didn't change. So it knows, the CLI knows, my procedures have changed or my procedures haven't changed. Now, if we wanted to make a new procedure, let's say, for example, we're going to make a new procedure that accepts, I don't know, foo as its input. And I'm going to make it to where foo just has, I don't know, foo is a string, bar is a int32, and I'm going to make a function that's just, I don't know, do thing. So just like with our other procedures, I would put in our parameters, which is what the client is passing to the server. After that, we just have our RPC event, which I'll talk about later, but this is something that just gives us more information about the request itself. So for example, I have access to the actual request right here, you know, request.method, you could get the headers, whatever, right? This is just in case you need more raw access to some of the core HTTP primitives, and you can actually extend your RPC event to add additional metadata to it as well. Now, I'm going to just make it to where this guy accepts foo and it returns foo. So it's really simple. We're just going to return our params because we're not actually doing anything. We're just returning the same thing back. Now, the last thing you need to do is if I go to my client, you'll see that I still don't have access to do thing. That is not available yet. And the reason why is because you need to actually register it on the app. So app, and I'm just going to do thing. And now if we check our client, you'll see that now do thing is an available procedure. Now, if I were to run my client, you'll see that we are logging out the expected response, right? So we just pass it in, we're getting it out, right? If I wanted to instead make it to where, I don't know, for example, we do this where and then here we're like, I don't know, we like multiply it by 2 or something like that. Then you'll see here that now it's doubled, right? Really simple stuff. But anytime we change any of these procedures now, the client will update accordingly and it'll say, hey, you're missing some required properties. That's basically the essence of how it works. Now, the way this works under the hood is that Arri is creating an HTTP endpoint that accepts JSON, and then it's validating the input to make sure that it actually works. So for example, if I were to actually curl the server, you know, /do thing with some empty data, you'll see that we actually get an error here. And actually, let me pipe that into JQ real quick. So you'll see here that, hey, we were expecting a string at foo, we were expecting a number, and we were expecting a Boolean. And if I were to do this again, where all of our types are correct, blah, bar is supposed to be a number, but then I make it to where this one guy is incorrect, you know, maybe it's a string instead. Now we get back a different error that's, hey, we were expecting a Boolean, you sent us a string, okay? So all of this validation is built into Arri RPC. And all of these standard primitive Go types are basically supported. So you've got your strings, you've got your numbers, including int32, and your standard integers. So as you know, Go integers, both uint and int, it's actually an int64 by default, which if you were to go into TypeScript land, that's kind of a problem because everything is a float by default, right? It's a float 64. So you actually lose precision when you go from Go to JavaScript. So because of that, when you have a type sent to int or int64 or uint, what happens is in the TypeScript client, this actually gets serialized as a string and it gets converted to a big int, because that's the way that you prevent essentially precision loss. If you didn't do this, you would actually get precision loss going from the client in the browser to the server. So we have to actually serialize it that way. But basically, yeah, we support strings, numbers, booleans. We've got dates using the time.time. We've got lists. You could also do your maps or records. And you can do nested objects as well. So now you might be wondering, okay, well then how are we supporting optional values and nullable values? And the problem with Go is Go has this concept of zero values, right? So if I call JSON unmarshal on something, what it'll do is that it'll create, you'll have an empty struct, and then the things that it can unmarshal, it will unmarshal it into that struct. If not, you'll basically get the zero value, which means it has no way of telling you whether the value was present or whether it wasn't present, right? Let's get rid of this. So if I were to make an endpoint that expected these two fields, Go's standard library won't actually tell you if the field was present when you unmarshaled it. You basically just get the zero value. So that's a problem. And so the way that Arri gets around this is that Arri has two helper types. And this, maybe it's controversial, I don't know. But this is what I figured was the best way to do this, is that we have these utility types. We have an option type, and we also have a nullable type. And the difference between these is that an option type can be omitted from the payload, while a nullable type, it has to be present in the payload, but it can be set to null. So if I hit save on this, what you'll see is that, okay, I'm not getting any type errors here, but I could just delete the name field and it's allowed. While this one now, date can be set to date, or it can be set to null. On the server side, when we're consuming this, what happens is that our option and nullable types, they actually have this is set parameter, and it'll tell you whether it was present or whether it was not present. You could also try to like unwrap or, so if you want some fallback, so for example, my name is params.name.unwrap or, some fallback value. You could do that. Or you could say, if params.name is none, then we're just going to return a error. And the same thing happens too with our nullable type. So we have params.date.unwrap or we have is set, and we also have like is null. So there's methods that are available on both our nullable and our option type that will tell you if the value was present in the payload or not. The same thing too happens when we serialize a response. So with an option type, if it's in the none state, which is the unset state, then Arri will actually omit that key from the payload. So, maybe this is controversial. Some of you might be thinking this is looking kind of similar to Rust, but I thought that this looked like the best way to approach that kind of problem. So that's some of our type helpers. In a future video, I'll probably go into more detail of like some of what this looks like in practice. But essentially, this is what Arri gives you, is you get a seamless RPC type system going back and forth between the server and the client. And if you watch my previous videos, you'll know that Arri supports clients that are written in TypeScript, Kotlin, Swift, Rust, Dart. And I'm looking to add more languages to that list in the future as well. So, but what that means though is that if you have a Go server and you start using Arri, you can basically generate a completely type-safe API client for free in any of those 5 languages: Rust, Kotlin, Swift, Dart, TypeScript. And that's really, really powerful. That really unlocks a lot of things. And some of you might be thinking, yeah, well, what about things like OpenAPI? What about, things of that sort? And I could honestly do a whole rant on this, but long story short, I don't think OpenAPI is very good. I've never liked the quality of the clients you get out of OpenAPI. I have always found them to be lacking, or if they even work, right? Because a lot of times they don't even work. If it even works, using them as a developer doesn't feel good. It doesn't feel idiomatic in the target language, and you run into all these weird edge cases. And maybe I'll do a video where I talk about some of my issues with OpenAPI and specifically JSON schema. But this is Arri. The other cool thing, though, is that even if you don't want to use any of these, RPC features that come with Arri, you can still use the validations and serialization standalone. So these same structs that are validating to make sure that JSON matches that same shape, you can use that standalone. Let's say we have some data here, and I'm just going to initialize an empty version of our greeting params. You can just call Arri decode JSON, and it will tell you basically if there was an error or not. So if error is not null, then you have all of the validation errors available for you here. So if you just wanted to use Arri for the JSON validation and serialization, you can also use that. And then basically you can say goodbye to all of these annoying struct field tags. In the same way too, you can use Arri to encode JSON, just like so. And, so this can all be used standalone, right? So if I were to run this, you see that this is printing out a validation message. Oh, we expected JSON, but we received nothing. If I actually passed in some valid JSON here, now this will pass. If I added another field, you'll see that we expected a Boolean, we got null, false. Let's do this now. Now you'll see that we have 2 errors being printed out. And let me make this actually pass now. And there we go. Nice. So whether you use Arri, the full RPC framework in your Go server, or whether you just choose to use it for the automatic JSON validation and serialization, that's up to you. You can make that choice. The only caveat that I will say is currently using Arri to validate and serialize JSON, it is going to be slower than the default JSON decode and encode. It's not going to stay that way. Primarily, I've just been working out finalizing the API, getting everything working the way that I want to. So I did the most naive implementation, but it is going to get faster. And I have been working on improving the speed of it in a private branch. But unfortunately, getting Reflect to run faster is not exactly straightforward in Go. You end up having to play with a lot of unsafe pointers and do a lot of really weird and unintuitive things to get it going faster. But that said, it will get faster in my private branch. We're already maybe just a little bit slower than the standard library, but we're encountering some null pointer exceptions and some, edge cases for stuff like that. So it's not quite ready, but it will get faster. The main thing is mostly for people to start trying it out, get a feel for it. Once the API gets settled and we're happy with the way it feels to work and use it, then I'll work on tuning the performance more. So if this project is interesting to you, then I encourage you to go to the Arri RPC GitHub repo. It's right here on GitHub. If you scroll down to the server implementations, you'll see that there is a guide for how to get started with Go. These things, it is kind of in early stages, but I really want to settle the API, make it feel stable, make sure it feels ergonomic to use. So if you have any feedback on what it feels like to use Arri and Go, please provide some feedback. We want to get people trying it out, seeing how it feels to use, and iterate based on that. In a future video also, I will probably do a more in-depth tutorial using Arri RPC with Go. I didn't even get into RPCs that make use of server-sent events and event streams, so you can actually get some real-time functionality out of Arri RPC as well. And I didn't even get into things like discriminated unions and using the RPC event interface to handle things like authentication and all that stuff. So I will probably have a more in-depth tutorial on using Arri with Go in the future. So look forward to that as well. But now that there's an initial Go implementation there, I'm curious, what other languages would you like to have Arri RPC working for? So we've got TypeScript server, we've got a Go server, and with both of these, you get a seamless end-to-end type-safe experience. What other language do you think would benefit from something like this? Right now, I've been looking at Rust, Dart, and Zig, but I'm open to feedback. So maybe leave a comment down below and let me know what language you think would be worth investing some time into to get an Arri server implementation going. But yeah, so that's all for now. So I guess peace.